All right, 7 things that we can say about this figure. What's one thing we can say about this figure? Like number of degrees for things, Evan. What's 52? Angle T is 52. It says it up there. What else do we know? Come on. This is 128. Okay, that can be 128. That's fine because they make 180 degrees, right? Okay. What else do we know? That's just one thing. The AB arc is 52 degrees. The BC arc is 128. 180. All right, now we're getting somewhere. Okay. What about AT and BT? They're congruent. What about BT and TC? They're congruent. So then, what do we know? What kind of a triangle is BTC? An isosceles triangle. So do we know what each of these little angles are? How big are each of the little angles? 26. How do you know they're 26? Because they share 2 angles, so they're each 26 degrees. Do you see? Okay, so 1, 2, 3, 4, 5, 6, and then the side 7. Yep, that's 7 things. You know, all the radii are congruent, so each of these angles, yeah. So I think we got enough there. Okay. Any relationship between angle ACB and angle ATB? Don?
Oh yeah, they're the same.
They're not the same. ATB and ACB, they're not the same. 26 is the same as 52? It's half of it. This is half of it. Because look, there's a 52 divided by 2. There's a 52 here, which makes 26 there. There's a 52 that relates to the 26. The arc is how much of this angle? Twice as long. The arc is twice as long as this angle here. So then we get to a relationship between what those are. Okay, an intercepted arc is here, an inscribed angle is here. An inscribed angle has a vertex on the circle, and its sides are chords of the circle. Okay? So that's when the vertex is on the circle, it's an inscribed angle. Angle Q here is a central angle. So there's a difference between a central angle and an inscribed angle. Okay, so an intercepted arc is cut off by an inscribed angle. Inscribed angle has a vertex on the circle. There's a central angle where the vertex is on the center. Inscribed angle is vertex on the circle. How if this arc is an 80-degree arc, how big would this angle be? 40. An inscribed angle is half the arc. An inscribed angle is half the arc. So if DG is 45.6 degrees, how big is this angle here, angle E? Angle E is 22.8. What about angle F? Why are they the same? Because they're both inscribed angles of the same arc. So two inscribed angles of the same arc are going to be congruent angles. Okay, congruent angles. All right, here's some relationships. How big is DH? Arc DH is 180 degrees. How big does this angle look? This looks like a 90-degree angle. Any relationship there? So if you have a tangent to a circle and a chord, then that makes an angle half of the arc. Okay? Given this angle, given this tangent and a chord, the angle is half the arc. So let's say this arc FD is like, let's say it's 80 degrees. How big would angle FHD be? 40 degrees. So then that would leave how many degrees for FGH? That would be 100, which would make JHF how many degrees? 50 degrees. The angle is half the arc. The angle is half the arc. The angle is half the arc. Okay? So, if you have an arc that's cut off by a tangent and a chord, the angle's half the arc. So if angle BDE is 65 degrees, how big is arc DFE? 130 degrees. Okay? All right, this is the only tough one of what we're going through. A person is standing against a wall of a circular room with a diameter of 24 feet. The person has a flashlight with a beam 15 degrees wide. What is the longest length of the wall that will be illuminated by the flashlight? Otherwise known as, what's this arc length from here to here? No. It's 30 degrees, but how long in feet is it? Now you got to put your thinking hat on. Because if their beam is 15 degrees wide and they're holding the light against the wall, it's going to, no matter where he is in this room, it's going to make an arc 30 degrees because the arc is half the angle, or the arc is twice the angle. The angle is 15 degrees. Okay? But how do we figure out how many feet wide this is? Then we got to go back to section 10.1. Section 10.1, we had a drawing like this. 30 degrees. 12 feet is the radius. Arc length. Arc length equals the angle divided by 360 times 2 pi r. So it is 6.28 feet if you do the math. That's what I got, and I didn't even use a calculator. Yeah. Yeah. You gonna explain your process? Yeah, that's what I thought. 30 over 360 is the same as 1 over 12. So this 12 cancels with this 12. So then it's 2 pi. 2 times 3.14 is 6.28. All right. So the angle is half the arc. 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 Okay? How big is the angle? All right, good enough. Is this very difficult? Hopefully not. So, let's get to the assignment.